Let's take a look at the energy level ordering and subshell capacity for electron configurations. Here's the energy level diagram for multi-electron atoms, with the energy going from lowest at the bottom to highest at the top. And we'll relate this to the structure of the periodic table and look at the order in which the subshells fill and how many electrons can fill into each subshell. So we start with the lowest energy that fills first. That is the 1s subshell, and that has a capacity of 2 electrons because there's one orbital and each orbital can hold up to 2 electrons. So that is 1s2 for its electron configuration. Now the next highest energy is the 2s subshell. That also has one orbital, 2 electrons, so that is 2s2. Next we have the 2p subshell. That has 3 orbitals, so 3 times 2 is 6 electrons maximum, and that is 2p6. We now move to the third row of the periodic table, and the 3s subshell fills first, 3s2. The 3p subshell fills next, 3p6. And then we go to the fourth row of the periodic table, and the 4s subshell fills. We get an electron configuration of 4s2. Next actually comes the 3d subshell, and that has 5 orbitals. So 5 times 2 is 10 electrons, and we have 3d10. And now we go to 4p, and 4p6 is the configuration for that part. Next up is the fifth row. We have 5s2 for the 5s subshell. Next comes the 4d subshell, and that gives us 4d10. After that comes the 5p subshell, and we have 5p6 completing the fifth row of the periodic table. We're now into the sixth row, and it's 6s2 first. Next, we actually go down to the lanthanides, which is 4f14. So the F subshell has 7 orbitals. 7 times 2 is 14. So that's the reason for that capacity. Now we're into the 5d subshell, back into the main part of the periodic table, 5d10. And then we complete the sixth row with 6p6. Now the seventh row fills out as well. It's not shown here. You can probably guess the pattern by now. It's going to be 7s2, then 5f14, then 6d10, and finally 7p6.